In winemaking, the sugar in grapes undergo fermentation by yeast to yield CH3CH2OH ethanol and carbon dioxide. During cellular respiration, sugar and ethanol are burned to water vapor and CO2. Using C6H12O6 for sugar, calculate the delta H reaction of fermentation and of respiration, combustion. Here we have the delta H of formation values, just so that we don't waste time, but they're not given in the question. So first we have to calculate for the fermentation. So we'll do the sugars undergo fermentation by yielding ethanol and CO2. So C6H12O6 yields CO2 and ethanol. Now you have to balance these equations. I already balanced them just so not to waste time. You're going to have to put 2 here and 2 here. And now we basically do delta H formation of products minus the reactants. So 2 CO2 plus 2 ethanol minus C6H12O6. And now to plug the numbers in, we'll do 2 negative 393.5 from here, plus 2 of ethanol, which is right here, so negative 277.63. Subtract that from the sugar, so here, negative 1273.3. So this turns into a plus. And now your calculation should give you negative 68.96 kilojoules. So that's how much energy is needed to undergo fermentation. Now for respiration for sugar, we're going to have to write the equation for combustion of sugar. H12O6 plus O2, CO2 and water, combustion reactions. And you're also going to have to balance this. I got this as for my balances. And now you do the same thing, so products minus reactants for delta H values. So 6 negative 393.5 for CO2 plus 6 times H2O, which is negative 241.826 minus the sugar. Oxygen doesn't have a delta H formation value. Well, it does, but it's 0, so it doesn't matter. So for the sugar, it's negative 1273.3. This turns into a plus. And the final value that I got was negative 2538.66 kilojoules. So that's how much energy you need for respiration of sugar.